But I want to show you something cool. Humans also produce a little methane in their farts. Don't try this at home. And so there's a balloon with oxygen and methane in it. Boom! Oh, sweet fireball of science. Redeem Academy. What is up, Science Squirrels? Johnny here with Redeem Academy. I'm here to help you get the most out of your education through content that gives God the glory he deserves. Hey, we're in the middle of our chemistry unit that is in the middle of a whole year of biology that I'm teaching. And today we're on lesson 5. It's all about chemical reactions. I'm going to show you a big chemical reaction. We're going to go over the basics of chemical reaction, and I'm going to teach you how to write chemical reactions. Hey, we want to thank our sponsor today, methane. This whole episode is brought to you today by methane, the gas that keeps on giving. It bubbles up from swamps, seeps out of landfills, and ripples out of the business end of cows. But don't be fooled, this humble fart fuel heats up millions of homes every day as natural gas, and even blasts rockets into orbit as high-tech rocket fuel. Hey, and if that doesn't make you want to hit the subscribe button right now and get your notebook at redeemacademy.org, then frankly, I don't know what does. All right, so we are going to start with methane today. Here he is, this magic molecule, and he is going to be interacting with a couple of oxygen molecules today. Now I'm going to put him down under the camera. All right, there is methane. Here are a couple of oxygen molecules, and they are going to go through what's called a chemical reaction. Now, whenever I teach about chemical reactions, I always am reminded of the time in college when I was walking down the street and I witnessed a car accident where a pedestrian got hit by a car. And what was amazing to me about this moment was watching the guy's shoes fly off as he went over the hood. Now, it was only about 20, 25 miles an hour, and I think he was probably okay, but because he was one of those cool gangbanger guys who didn't tie his shoes. But I was just amazed as his shoes went flying in opposite directions because of the massive collision that he had with that car. Now, in chemical reactions, there is what's called the collision theory of chemical reactions. So methane and oxygen, they can hang out in a balloon together without reacting, but if you get them hot enough, if you light them on fire, they will react. So we're going to see some methane today in a minute that's right next to oxygen, not reacting. But if you bring a little spark to them, bring a little flame to them, they get going faster, and when they get going faster, they will react with each other. Okay, so here is our boy methane. And he is a carbon with 4 hydrogens. And I am going to simulate a chemical reaction where these two oxygens come flying in at high speed and they slam into methane. Now they hit so hard that all their shoes fly off. Now at the same time that they slam into each other, they all fly apart, there is some kind of force that brings them all back together. But the weird thing about a chemical reaction is the atoms get rearranged. So they all come apart, but then they all come back together, but they come back together in a different form. So what starts out as methane and oxygen is rearranged into carbon dioxide and water. All right, so let's see what this looks like in real life. So I actually just did this in class 4 or 5 days ago. This is a demo. I put methane in that white balloon. You can see I'm bringing it up to a torch here. A kid filmed it on his iPhone in slow-mo. And I do this every year. And so there's a balloon with oxygen and methane in it. Boom! Oh, sweet fireball of science. So beautiful. I was a child who played with fireworks. And in Oregon, we have what are called illegal fireworks. You can't get them in Oregon, so you have to go to Washington. I think you can get them in Washington. I got them as a child on the way to visit our grandparents in Colorado. We got them in Wyoming. Bottle rockets, M80s, things that explode, things that shoot into the sky. I had a big sandbox as a kid. That's great when you're little. When you're in middle school, that's where you blow things up. I was basically Sid from Toy Story, only I didn't like to torture toys. I just like to blow stuff up. That has evolved into me being a chemistry teacher who likes to blow things up for his students. So let's back this up. What's going on here is there's a balloon full of millions of molecules of methane and oxygen. And right here, the balloon pops. Now, that torch always goes out for this, but it's given off enough flame to ignite the first burst of methane that came out of the balloon. You can see little balloon parts that actually fly out. And then more methane has ignited. That methane gives off a bunch of heat as it reacts. Okay, so the first bit of methane catches fire from the torch. Torch goes out, but that methane gives off heat. That methane gives off heat and ignites the next stage of methane, or just all the molecules near it. Then that gives off more heat and ignites the next chunk of methane. Methane is less dense than air, so it actually goes up. So as the balloon pops, a lot of the methane goes up, and we're giving off a bunch of heat. This is an exothermic reaction. So then it starts catching all the methane near it on fire, keeps doing that. Oh baby, it's starting to really spread, keeps spreading, spreading, spreading. It starts catching the methane on fire that is above it. Also heat rises. Also there's probably molecules around it that haven't gotten any oxygen yet, so they're starting to catch on fire, and we get this beautiful fireball of science. And you can see me, I'm a little pyromaniac over there, still enjoying every minute of it, even though I've done it 10,000 times. And the last little bits of methane burn out. Beautiful reaction. All right, so let's draw this chemical reaction. This guy right here is methane. He has a central carbon atom. Let's draw it black. Okay, he cannot undergo a chemical reaction without oxygen. And he doesn't just need one oxygen, he actually needs 2 molecules of oxygen. Oxygen looks like a baboon butt. Okay, now we draw what's called a yield arrow, which means that the reaction proceeds in this direction. So this is our methane. Okay, you saw him already. This is our methane. These are our oxygens. You saw these guys already. Okay. Now a little more of a close-up of our CO2 molecule, carbon dioxide. So we're going to draw him as black in the middle and 2 reds on his outsides. And finally, we produced a couple of water molecules. These 2 red guys right here. All right. Let's get those out of the way. Let's name these guys. This is methane. This is oxygen. It yields carbon dioxide and water. Okay, this whole thing is called the methane and oxygen reaction. All right, so a little bit about methane. Methane is natural gas, or it's one of the main things found in natural gas. When they drill into the earth to find oil, they also get gas that comes out. And one of the main things that's in that gas is methane. But also, cows fart. And when cows fart, the main thing that comes out is methane. In fact, they fart so much that dairies and other major farming operations can actually collect their farts and actually power the heating systems of the facility with methane. Also, humans produce a ton of garbage, and when we bury the garbage underground, it will actually produce methane, and we can use that methane to heat our homes and do other things as natural gas. But I want to show you something cool. Sometimes cows get a little backed up, and you have to poke a little hole in them to help them out. Check this out. All right. What is going on with this cow right now? He looks like he has like the pump, the needle to a bicycle pump sticking out of him, and it's got a flame coming out of it. Watch this.
By puncturing a hole in the side of the cow, the farmer is then able to insert a tube. Now, this is done on cows that are extremely bloated due to an accumulation of gas in their digestive system. This buildup creates pressure that can make breathing and blood circulation very difficult. The procedure allows the trapped gas to exit the cow, and some farmers even light it on fire to burn up the methane as it releases.
That's crazy. I kind of wonder if they light it on fire just for fun.
Save a cow's life. As cows experience bloating, this method is typically carried out by a veterinarian who punctures the stomach to release the trapped gas. And this procedure is crucial because excess gas buildup can be fatal to cows if left untreated. And a considerable amount of this gas is methane, which can ignite.
Okay, that dude is straight smiling while he's doing it. Okay, are you doing that for the cow, or are you just doing it because you're a pyromaniac like me and you like to play with fire?
Upon exposure to fire.
Okay, so the tube they put in is called a cannula, and I think this cannula is a little bigger than the other ones we saw. Check this out. Holy moly. Okay, this cow's like, hey, what you doing there? Why is there a flamethrower coming out of my stomach? That's quite a superpower. Now, humans also produce a little methane in their farts. Don't try this at home. Okay, so the flammable gas, which is the main thing in natural gas, is called methane. Now, if you have pure methane, it's not going to burn. So they can light that cow on fire, and it's not going to go into the cow's gut and blow the cow up because there's no oxygen in the cow's stomach. You can't have a reaction without both things that are needed. So oxygen is found in our atmosphere. You might think, oh, the air around us is 100% oxygen. Actually, most of the air around us is actually nitrogen. Only about 21% of the air that we're breathing in is oxygen. Now, when I do my demo, I actually don't even use regular air. I blow air in to the balloon. And so when we breathe in 21%, but we breathe out 15%. So I actually like to put less oxygen in that balloon because it makes the fireball take longer to burn up. And so 15% oxygen coming out of my breath still is enough to make that fire burn nicely. Other people will use pure methane in bubbles. Check this out. So this guy has bubbled methane up through soap, lights it on fire, boom, and he gets all the oxygen he needs from the air around him. So I put a little bit of oxygen in that balloon so it still goes, and then it grabs all the other oxygen it needs from the air around it, okay? So right at sea level, we're at about 20.9% oxygen in the air, about 21%. That is oxygen O2. Now, once you mix the two together, you get water and carbon dioxide. You've already heard me talk a lot about water. Carbon dioxide is what we breathe out in addition to oxygen. As we break down the food we eat, carbon dioxide is the byproduct. We actually lose weight by breathing out carbon dioxide. These carbon atoms are how we lose weight. You don't lose weight by pooping or peeing. You lose weight by breathing out carbon. But don't hyperventilate because you have to exercise to get more of these carbon atoms to come out. You breathe in the two oxygens, you add a carbon to it, you breathe it back out. So unless you're breathing in more oxygen because you're running, then you're not breathing out more carbon because you're not breaking down fats and sugars. That's really kind of depressing when you think about it. So I have to breathe one of these in and then add a carbon to it, and then breathe it back out. That's how slow weight loss happens. But it's a lot easier to eat a whole Snickers bar. Like, I can eat a whole Snickers bar really fast, but I can only breathe out one carbon dioxide at a time. Oh, man. I'm never getting rid of this dad bod. All right, now I am going to add two words to this. I'm going to put a little brackety bracket right here. These are called reactants, and these are called products. And like you saw in my little animation where I came and put these together, the reactants become the products. So this carbon atom is now that carbon atom after everything's been lit on fire. These hydrogen atoms are now those hydrogen atoms. These oxygen atoms are now those oxygen atoms. Everything still exists, it's just been rearranged. So number 4, the rearranging of atoms and molecules to form something different, this is what a chemical reaction actually is. Okay? Now, we don't in chemistry normally draw out these wonderful, cute little pictures that I made. Normally, we just do it with math, and this is called a chemical equation. Okay? And so down here, I am going to draw a chemical equation of what is up here. So this guy right here, methane, is 1 carbon and 1, 2, 3, 4 hydrogens. 1, 2, 3, 4. So we write this as CH4. Now remember that this thing is called a chemical formula. So methane's chemical formula is CH4. And we have the chemical formula of this guy. One of them is called O2. The oxygen we breathe is O2, but there isn't just one of them, there's 2 of them. So how do I draw that? Question mark, 2O2. So there's 2 molecules of O2. Now I'm going to draw an arrow, same yield arrow shows up over here. And these guys react with each other to form the products. This guy, that's a carbon, those are 2 oxygens. You know this guy's name, you've said it out loud before, CO2. That is the chemical formula of carbon dioxide. And then I'm going to put a plus. Oops, I forgot my plus up here. And you've definitely said this guy, H2O, some high quality H2O. His name is H2O, and because there are 2 molecules, I'm going to put a 2 in the front here. Okay? A mathematical representation of a chemical reaction is called a chemical formula. And those guys who are about to react, remember them? They're called reactants. And the ones that get made, they're called products. Let's write those down. The chemicals about to react, reactants. And the guys who get made, products. Okay, now, another important thing to notice is we don't write all of the molecules that are actually present. So look at my little demo here. Right at the moment that my balloon pops, boom! There are trillions upon trillions of molecules of methane being lit on fire and reacting with twice as many trillions of molecules of oxygen. But my chemical equation just says 1 molecule of methane plus 2 molecules of oxygen. That's because in a chemical reaction, or in a chemical, this should really say equation, the numbers are written in simplest form. We don't try to represent every single molecule that's actually present. It's really hard to do that kind of counting. You can do that in a high school chemistry class, but when we just write out the chemical equation, we're just trying to show for every methane, how many oxygens do we need? We're just trying to keep it in balance, okay? Like when we have fractions, if we say 3/4, that's nice and simple. We wouldn't try to say 300/400ths. That would be kind of strange. We keep it as reduced or in as simplest a form as possible. That's how we write chemical equations. Now again, very important to realize these atoms are the same atoms that end up over here. Here's another way of thinking about this. When I pour gasoline into my truck, every 2 weeks I got to fill up my truck with gas. 1 gallon of gas weighs about 8 pounds. My truck holds about 20 gallons of gas. So there's 160 pounds of gas that goes into my truck every 2 weeks. I light it on fire inside the combustion chamber of a V8 engine, and after 2 weeks, it's all gone. 160 pounds of gas. Where did it go? Does it no longer exist? No, it still absolutely exists. Another question just like this. We burn firewood at my house, okay? We probably bring home 6 cords. That's probably somewhere between 6,000 and 12,000 pounds of firewood every winter, and we burn it all up. And other than maybe, I don't know, a wheelbarrow full of ash that weighs maybe 50 pounds, all the weight is gone. Does that mean those atoms don't exist anymore? No. Where did the gas go? Where did the firewood's mass go? In both of those situations, they become gases. And it's weird to think about, but gases, like air, actually has mass. So if I was to put a giant plastic bag over my tailpipe of my truck for 2 weeks and capture every ounce of gas that comes out of the tailpipe, it would weigh exactly what the gas weighs when I pour it in as a liquid. Same thing, if I were to put a giant plastic bag over my chimney for 6 months that we heat our home, or 4.5 months that we heat our home, the weight of all the gas that comes out of the chimney would weigh the same as the weight of all the firewood we put into the wood stove. What happens to the atoms is just that they get rearranged. And with firewood, they go from being a solid to becoming a gas. And with fuel, it goes from being a liquid to a gas, and it floats away into the atmosphere. Okay, so this idea of what happens to atoms and molecules when they go through a chemical reaction is they still exist, but they get rearranged. Now, in both of those cases, what we actually use the fuel for is to get energy. And you can think of energy being found in the bonds of molecules. Now, I've got a way I explain this to my students. I don't know if this will make any sense to you. Depends if you've ever played with this weird toy before. When I was a boy, back in the 1900s, we would go to this place called Skateland. It was a skating rink. And you would play video games in one of these big box things. It would give you tickets. And then I would take my tickets, and one of the weird things we would get was a sticky finger. Whoosh! And one of the other weird things we would get was this ice cream cone that was actually a ball on a string that you could shoot your friend in the face with. The 90s were a weird time. It was actually kind of a nice, innocent time. So here is this little ice cream cone toy. Raise your hand if you've ever played with one of these. No? Just me? So what you would do with this toy is you'd go up to your friend and you'd be like, hey, want a lick of my ice cream? And even though all of us had bought one of these with our tickets at the skating rink before, we'd go, oh, okay, and boom, shoot him in the face. Here's what I want you to think of as how atoms' bonds contain energy. You would take that little foam ball and you would push it down on a spring and you would click it back in, and you'd go up to your next friend and shoot him in the face with the ice cream cone again. That little bond of clicking the foam ice cream cone ball back in and having it charged and ready to shoot out again, that's how I want you to think about atoms. Every time an atom forms a bond, think of it as compressing a little spring. And that spring is charged up and ready to shoot out again at any moment. That's a good first understanding of how bonds work. And this brings us to our last point, which is, for me, the most exciting thing to talk about today. This last idea is called the law of conservation of mass. Okay, the idea that matter cannot be created or destroyed is called the law of conservation of mass. Now, this is an idea that I think it was a guy named Lavoisier. If I get to where I teach a whole chemistry year, I'll do a what is chemistry unit, and Lavoisier will be the star of the law of conservation of mass. He figured this out in 1700s, but basically for a long time people thought you could get rid of matter, that it would be destroyed, like I talked about. The firewood, it's gone, it doesn't exist anymore. Or the gasoline, it's gone, it doesn't exist anymore. Lavoisier figured out matter never gets destroyed. It keeps existing. And this law almost sounds like it's like a law that God can't exist. Matter can't be created. Not at all. The law of conservation of mass is actually an extremely good argument for the existence of God. Imagine a universe where there are places where matter just spontaneously comes into existence. That would really kill the idea that God exists. If there's just like this random thing called a white hole, like the opposite of a black hole, and out of a white hole, matter is just being emitted, and it never existed, and now it exists suddenly. It'd be hard to explain a universe like that because, oh, there's a chemical reaction and now new atoms exist that never existed before. But instead, we live in a universe where all the matter that exists already exists, and there's no known way that it could come into existence. That's a huge problem if you're an atheist. Why is there matter to begin with? Okay? And this brings us to our big question. I'm actually going to go to the notes to answer the big question today. Check this out. So big question says, if matter can't create itself and doesn't keep appearing, what's the best explanation for where it all came from in the first place? So there's a really good answer for this, and I mentioned it the other day. It's called the Coulomb cosmological argument. Now, this is a completely theological argument. This isn't an argument from the Bible. This is just an argument from logic, but it's an argument from logic that says, hey, there must be a God. Check this out. There's only 3 points to this argument. First point, everything that comes into existence must have a cause. Point 2, the universe came into existence. I think I spelled existence wrong. Point 3, the universe has a cause. Mic drop. Okay, so if those 3 premises are correct, really if the first 2 premises are correct, the third premise follows. Okay, this is how logic works. If all things that come into existence have a cause, and if the universe came into existence, then the universe has a cause. Now, what is big enough to cause a universe? Something that is outside of the universe, the universe has time in it, so something that is outside of time, something that is extremely powerful, something that is personal, because only a personal thing could choose at a specific time to create the universe, because the universe came into existence at a certain moment. Okay? And we're getting to a place where we're starting to sound like God. And what's cool about this is all just based on logic. I've sat with people who are atheists and just worked through this a little bit. It starts to convince the skeptical. It's a really fun way to get from logic to God. And ultimately, I think people don't become Christians usually because of logic. What you need to become a Christian probably is to first see that it's reasonable, and then faith is that step beyond reason, the step after reason. So first I need to know that Christianity is reasonable, and then it's this step into the unknown after reason. After I see that Christianity is reasonable, I take that further step into the unknown and love God. But it's fun. It's fun to show that Christianity is a reasonable, logical thing. And so maybe for you, this clicks, this makes sense. Maybe it's something that, like, at your age, I probably would have been like, this guy is so strange. What is he even talking about? But it's something that I very much enjoy now that I'm a little older, and I can appreciate it a little more. I remember learning about proofs. That's called a proof. I remember learning about proofs in high school geometry and being like, what is this? Words and math. Hopefully you can appreciate the Kalam cosmological argument. It's probably one of my favorite arguments for the existence of God. Hope this lesson was fun for you. Peace out, Girl Scouts.